This begins lesson 8.3 part B. We just got done looking at the table, okay, saying that these observations can be made. So if we look at this question here and we see that we are given this function, what can we say happened? Alright, well, the negative 1/2 means it's going to open downward because it's negative, and it's going to be wider because it is a number between 0 and 1. The negative 2 inside the parentheses, so minusing 2, means it's going to translate. We said it's opposite of it's inside the parentheses. It's affecting a left and right shift, opposite reaction or opposite effect. So -2 is going to go translate right 2 units, and then the 3 out here is affecting vertical shifting, and that will translate down, because it's minus, down 3 units. Now remember, the original function y equals x squared is up here. The negative made it go downward instead. The 1/2 made it narrower, or excuse me, wider. The shifting of 2 units to the right sent it over here 2 units, and then down 3 units, and this is the graph we ended up with. The vertex shifted from the origin to that point. Next one. Now there's a 1 in front of here, so that means it did not affect the narrowness or the width of the parabola. It's normal. The 1 here is what we're talking about here. What did that do? It translates, or translated, 1 unit to left, because +1 we do opposite, shifts left and right movement is inside the parentheses, and it's opposite reaction or opposite effect. The -2 is vertical shifting, and that affects as it is, so this is a translate 2 units down. Okay, so the graph was here. It shifted to the left 1 unit and down 2. So now here is the new vertex. So it was at 0, 0, and now it's at -1, -2. Alright, so describe how to translate, or describe how to translate the graph of f of x equals 0.4 x squared in order to produce these graphs. Alright, so describe what's going to happen. Well, this one is going to, because now the 0.4 is a given. Now this is not the parent function, but that's what they're starting with. So if you start with that, what happens? Well, this one is shifted. Now it's not inside the parentheses, it's outside. It's affecting x squared. It's -1, so it's a vertical shift. Now I'll say translate 1 unit down. This one is inside the parentheses, so that means it's going to translate 7 units left. Inside the parentheses is a left and right movement, and it's opposite of what you think it would do. Next one. This, if we look at the inside of the parentheses first, it's going to translate, I'll do 2 things at once, 2 units, And it's -2. Left and right movement is inside the parentheses, so -2, opposite effect. So 2 units right and 9 units up, because it's outside the parentheses, as is vertical shift. Next one, again, translate 3 units. Inside the parentheses is a left-right shift, opposite effect, so -3 is a 3 units to the right. And 6 units. Outside the parentheses is a vertical effect, and it's as is, so 6 units down. All those things. Alright, now why do they call it vertex form? Well, if you notice, when you look at this and you say, alright, I'm going to translate, now the parent function is here. That's the vertex of the parent function. Okay. Now I'm going to shift that parent function to the left 6 units and down 14. Alright, so instead of my vertex being 0, 0, take this off of there. Instead of it being 0, 0, I shift left 6 units, so it goes over to the left and down 14. So now my vertex is left 6 down 14. It's right here. So this vertex, now the 1/3 will make it wider, okay, but that's not what the question is referring to. The question is, what's the vertex? And the vertex is -6, 14. Now, that's very easy to find when it's in vertex form. If you remember, in standard form, we had to do a lot more work. We had to find the line of symmetry, plug that x value in, and then that gave us the y, so we were able to find our vertex that way. In vertex form, it's very quick and simple. Y-intercept. Now again, I'm going to reference this. Standard form, in standard form, this is the y-intercept. Okay, because if I plug in 0 for x, that cancels out and that cancels out. But in vertex form, it doesn't work quite that easy. We still would do the same thing. We would plug in a 0 for x, and we would see what we'd get. So a lot of people would say by accident that 14 or -14 is y-intercept, but that's not true. We still have to plug in 0. If we do that, we get y equals 1/3 6 squared minus 14. Y equals 1/3 of 36 minus 14. So 36 divided by 3, or times 1/3, is 12 minus 14, and that's -2. So on the graph, our y-intercept would be -2, which would be up here somewhere. So if we take our graph, -2, so our y-intercept would be up here. Again, this is wrong though, because that's not where our vertex is. Okay, so a little bit more work in terms of finding the y-intercept than in standard form, but the vertex is quite easy. Alright, so this one, vertex, well again, if we look at the graph, we can tell right away that this opens downward. Okay, so it's going to be like this. Right here tells us it's going to shift to the left 1 unit, and this one's going to tell us that it shifts down 4 units. So again, the parent function was at 0, 0, the vertex was at 0, 0, and now it's at left 1, down 4. This is the new vertex. Now the negative here says it opens downward, so it'll be something like this instead of right here. Okay, so the new vertex is -1, -4. What's the y-intercept? Well, we plug in 0 for x, so it's -0 plus 1 squared minus 4. 1 squared. 1 squared is 1. This -1 is still sitting there. And we get -5. That is the y-intercept. So if I were to fix this graph, and write down that the y-intercept, or the vertex, is at -1, -4. Y-intercept is 5. That would be mirrored to there, and it would be something like that. Not a V, but a U, remember. Okay, there's lots of things in this lesson. 8.2 is a very important one, but it is quite interesting because now we're graphing it with a different form, that being vertex form instead of standard, and we can get a lot of perks from using vertex form. And plus it's fun to see how the graphs are affected as you add and subtract values when it's in vertex form. If we did it in standard form, it would not be as fun, but in vertex form it is. Alright, this ends lesson 8.3, part B.